guys, last time on 5.4 we talked about some integration rules, which are the 5 like basic rules for integration, and we also mentioned about fundamental theorem of calculus, FTOC, which allows us to plug in the upper limit and also the lower limit to get a value after we integrate the functions, right? And that is like really useful in calculus in general. And we also talked about the even odd functions, which allows us to use them as a shortcut to like simplify our procedure of integration. For example, if you have for odd function, if you have from, I don't know, from the -1 to 1, then the answer will be like 0 without doing any work, right? Because like the area is one positive and the other one is negative, they will cancel out anyways. And for even functions, say we go from like -2 to 2, or I don't know, -4 to 4, then we don't have to do like all the way from negative number to positive number, but we can cut it halves and then double it up later. Okay, so these are like the shortcuts to integrate a function if they happen to be even function or odd functions. Okay, and also we talked about like how to integrate a piecewise function. For example, the last time we talked about the absolute value function, but say if I'm gonna give you something like, I don't know, like a flat line here, and I don't know, maybe like there will be some sort of like downward curve in here, and they should be connected or not connected is not going to be like matter a lot. Say if I'm gonna have like a jump in here, and then I don't know, it's gonna go like up or something like that. How can I integrate this function, I don't know, from say -5 to 4, something like that? Well, we have to break it down into like 3 regions, right? So the first region is going to go from -5, for example, all the way to like 1 in here, because it's the part where we have the constant function, and for this level I'm going to say is like y equals to 1. And then another chunk is that we're going to have to break it down in here, so say this is like 2, and then for that piece right here we're going to have, I don't know, something like y equals to -3x, I don't know, like +4 or something like that. And then the last piece, we're gonna have it going from 2 all the way to 3. So this piece in here, you can be super creative with this one. I'm just gonna make it up. I don't know, something like 2x plus a half or something like that. And honestly, the functions in here, the one in pink highlight, these are from the problem, okay? So you don't have to like create them like what I do right now. But what you need to do is that you're gonna cut them off into like 3 pieces to integrate a function, okay? Because obviously this is not like a continuous function, right? Like it has some branches, it has some parts in there, so we have to cut it off when it comes to the limit of it, okay? So we're gonna have like 3 areas in here. The first area is like this shaded region in pink. The second area, you're gonna have this little guy in here. That little piece in here, I cannot like do it, but if you want, you can like color it like this, and then if you project it toward the x-axis, you're also gonna have this like red region in here. That's like the second region, right? And then the last one, let me rotate it in green, in shaded region. So to find the integral of this function in here, it has like 3 parts, right? So then we're going to integrate each part separately, and then at the end we're going to add all of them together, okay? And obviously this part in here in red, this guy in here is going to have a negative value, right? And then the pink area in here is going to have a positive value, and then the green one, it should also have a positive value. And the other piece in red, this one should also have a positive value, right? Because they are aligned on top of the x-axis, so it's positive, and if you happen to have the region underneath the x-axis, then it's going to be a negative region, okay? And the last time we also talked about the annuity. The annuity is pretty much just about the formula. You plug it in, and then you get the annuity that you like invest, and then that's pretty much just it. Just like, you know, you apply the formula, plug, check, you're done, right? So now let's talk about the content of 5.5. Okay, first off, we have area of region bounded by 2 graphs. Okay, so the last time we just talked about 1 function, right? But this time we're going to have 2 functions, f and g. And obviously one will be like, you know, like on top of the other function for like the examples in here. In each of the picture, we can see that F in here is on top of G for this part, but then F is underneath of G for the little tails in here. You know what, let me use a color code for this one. So red for, you know, like upper or like on top, and then I don't know, pink for under or on the bottom, right? So what you need to do is that, well, sometimes it's going to be like F minus G, and some other time it's going to be like G minus F. Okay? And, okay, so how can we integrate it? All right, let's talk about the first like bullet in here. With a few modifications, we can extend the use of definite integrals from finding the area of a region underneath under a graph to finding the area of a region bounded by two graphs. All right, so the question is asking us for this region in here, okay, because we have it going from like A to B between, you know, like F and G. And between A and B, F is on top of G, right? So in here, we're going to have like F minus G, okay? But like just like a heads up in here, we're not going to talk about it for this page, but just a heads up in the future for this little pink curve in here and the little pink curve in here. As you can see, F is underneath of G, right? So if you want to do integration for them, you have to do G minus F instead. Okay? And now, if we want to calculate the area, the shaded area in red in here, well, we have to think about the area in here, like in green first. That's the area underneath of F compared to the x-axis. And there's like one more area of G with the x-axis, right? Excuse me. All right, so to get the red area, we're gonna do green minus blue, right? So then this one, this is the red area that we want to calculate. And then this one is the area underneath of F, or the green area. And this one is the blue area, the area underneath of G. Okay? So then, how do we do it, right? So then, technically we have to do subtraction between the two. Okay? And because we have the limit, right? We have the upper limit, which is B, and the lower limit, which is A. So with the use of the fundamental theorem of calculus, we can plug in A and B at the end to figure out like what number it is for each area, right? And after that, we subtract them to get the red shaded area, like from beginning. Okay? So in summarize, like to as in a summary, area of a region bounded by two graphs. If F and G are continuous on the closed interval from A to B, and G is less than or equal to F, meaning G is like under F, as for graphing, for all x in the interval from A to B, then the area of the region bounded by the graphs of F, G, and x equal to A and x equal to B. Okay, so what does it mean by this, right? Like, let me just cut this thing off, and I'm gonna show you what it means by those four region. Okay, so F, we know that F is like this piece in here, and then G is for this piece in here. And then we talk about x equal to A, which is this like junk in here. And then x equal to B, which is this vertical like piece in here. So you want this area, like this is the area that you want. Okay? Is given by this formula right here, where F is lying on top of G, so we go F minus G, going from A to B, because those are the given limits from the problem. Okay? After this, well, we're gonna go ahead and combine like whatever line terms that we have, break out the parentheses, distribute the negative if you were to have like more than two terms. And after that, plug in, we have to integrate first and then plug in the value B and an A and then subtract them. Then we get the answer, okay? It's gonna make more sense when we talk about the example in the next page. But for now, that's like the procedure, okay? And now the next bullet. Sometimes two graphs intersect at more than 2 points. To determine the area of the region bounded by two such graphs, we must find all points of intersection. So this one, just a quick highlight here. We have to find all the intersection. That's the first step. And after that, check to see which graph is above the other in each interval determined by the points. So this one is really important because whichever like function that lies above the other one, it should be the first one to be like minus, right? Like in here, for example, f is on top of g, that's why we do f minus g, right? And then for this little piece in here, I told you guys already, because f is underneath of g, that's why we have to do g minus f rather. Okay, so it's really important to know the position of the functions that you're having. All right, so for my personal tips, for now, we find the area bounded by two regions by integrating with respect to x. So we can simply think of it like top minus bottom in terms of the two functions, right? So whatever function that lies on top, we minus it to the function that lies on the bottom, okay? Top minus bottom. However, it is some other times easier to integrate with respect to y, okay? And if you were to integrate with respect to y, you're gonna get something like, I don't know, like integral from c to d of some function f in terms of y this time, minus g in terms of y again, and the variable that we have in is y, right? And my d looks ugly, so let me go ahead and fix this really quick. So if we were to have it with respect to y, then we have to do right minus left. So what does it mean, right? So say you're gonna have a graph to function, I don't know, like this, and maybe something, okay, let me make some, okay, this one, a linear function, and maybe a parabola. Okay, so for this one, you know what, let me use like color code for this one. Let me put this, the other one in pink. Okay, that's the best I can get. All right, and say for example, if my a is like 0 and my b is, I don't know, like right here, which is like, I don't know, 5. Okay, because we're talking about with respect to y, right? So we're gonna do right minus left. So for this area in here, let me change the color to, I don't know, blue. This area in here is gonna be pink minus red. Okay, so the blue one in here, let me just put pink minus left, minus red. But if we talked about this area in here in I don't know, like purple, okay, and just a heads up in here, 5 is a cutoff point, right? So then let me just like mark it down here, and then let me extend both functions a little bit so that you can see the importance of them. Something like this. So then this one will be a little bit like that, and then let me extend the 5 over here. So then this one is also like another intersection of the line x equals to 5 to both of the function. Then the purple area in here in between, this one it equals to what is it? Okay, so this purple function in here, let me make like an arrow in here. Okay, so this one though, okay, to my advice, it's really hard to tell which one is left and which one is right? So, but obviously the pink function is lying on the top of the red function, right? So if I were you, I'm gonna do pink minus red, but this one is in terms of x, and the other one, the blue one, I'm gonna do it in terms of y. Okay, so what variable should we use? It really depends on the position of the functions. Okay, if it's not like obvious to see like the purple one in here, then you can switch a variable and change it back to top minus bottom. Okay, but if it's like in general, if it's like common, like the blue area in here, then you can think about it like top minus bottom or right minus left. It really doesn't matter, but then the results should be the same. Okay, so if you want, you can try to be creative with this one. I mean, if you want, let me give you like some functions in here, like some real life functions, so then it will be a good practice for you if you want to try it. So this one I'm gonna say is like x, and the other one, the parabola, I'm gonna say is like equals to, I don't know, x squared or something like that. Okay, let me move this one a little bit further. Okay, so then you can think of it like x squared minus x or x minus x squared, and then play around with it, and then make sure at the end you should end up with the same function regardless what variable you use. Whether it's x or y, they should have the same value for the area. Okay, so now to make more sense of what we've been like discussing, right? So let's talk about an example. So the first one on my part, okay, the instruction is that we have to find the area of the region bounded by the graphs of f of x and g of x and then sketch a graph. Okay, so how can we do it, right? So we have like two functions in here. Let me put this one in red and this one in pink. So first thing first, you have to sketch it, okay? Like in the homework or in this test, I'm not going to give you the graph, and you guys have to know how to graph it sometimes, okay? But I promise you guys, it's going to be like some decent function. It's going to be either a linear function where you just go by rise over run, or it's going to be some parabola where you have to like plug in points and then connect the points together and then you get the graph, okay? So for graphing, it's just going to be either a line or a parabola. It's not going to be something crazy, okay? So anyways, if you want to, first step first, we have to connect we have to draw the graph, right? We have to sketch the graph to know which function is above, like which function, right? So how can we do it? Well, if you remember, like back in the day when we completed square for the circles, we're going to do the same thing pretty much for this one, okay? So for this one in here, if you want, actually, there's another easier way. You can like connect them by, by using the table of x and y, okay? So in here, let me give you like a vertical xy table rather than a horizontal one like this. And I'm going to ask you to give me like 5 values. So let me put 1, 2, 3, 4, 5. Something like this. Okay? 5 random x values. But there's like a way for you to choose the x value. It's not going to be random, actually. So first thing first, right? Like what do we do? Well, what we're going to do is that we're going to take the middle term. Let me highlight in red. This one, we divided by 2. Okay? So we all know that negative 4 divided by 2 is negative 2, right? So that would be our center, which should be on the third box, or on like, you know, I mean like the fourth row, but you know, like the third like chosen number, okay? And then for the other numbers, we're just gonna go off from them. So let me put it in green. So this one, I'm gonna go like a little bit up, so it's gonna be like negative 1 and 0. For the other direction, it's gonna be negative 3 and negative 4, okay? So all you need is a good calculator in here. So then now what you're going to do is that you plug in all these x values into the function, the original function that we have. So let me give you some minutes to do that, and I'm going to do it with you too. Okay, so for 0, I'm going to get 3. For negative 1, I have 8. For negative 2, I have 15, which is a big number, but well. And then what else? For negative 3, we have 24, which is a bad sign because I thought it's gonna go down to 8. Give me 1 second. Let me think about like the reason why it happens to be like that. Oh, I know. Okay, so one thing I need to tell you is that you have to switch a sign. Here, let me go from the beginning again. So this one, you take the middle number, you divide it by 2. That gives you a negative 2, right? Don't go with that. Change the sign of it to 2. 2 is what you want, not negative 2. Okay, that's my mistake. I keep doing that for like so many years. I don't know why. Okay, so let me go ahead and take out the negatives in here. Okay, and now let me try that one more time, and you guys will see right away like why the logic in here is right. Okay, so let me try 0 again, which gives me like 3, and then if you plug in 1, you're gonna get 0, and then plug in 2, get negative 1, and then if you do it right, it should come back to 0. Okay, so if you notice, there's a symmetry in here, right? That's why earlier, right off the bat, I know that I make a mistake because the numbers are not symmetric. Okay, so this is like a good test for you to know in the test whether your number, like your 5x numbers, are right or wrong. Okay, And then the last number, if you do it correctly, it should be 3 for the symmetry in here. Okay? And now, this is 3. Okay, you're gonna plot them, right? So 0 and 3, it should be right here. And then 1, 0, right here. 2 and -1 is right here. And then 3 and 0, we got it down ready. Oh wait, 0 and 3, there we go. That's like the point I'm missing. And then 4 and 3 right here, right? So connect them together, you're gonna get this graph in here. I try to like trace it, but you know what I'm saying, it's not a perfect trace, but there we go. Okay, and the other one, because I put it in blue, so let me go ahead and change the color to blue really quick. Okay, we're gonna do the same trick, right? So for this one in here, I'm gonna go ahead and highlight the middle term in here, which is 4x. Okay, just in case you guys wonder like what it means by the middle term, I mean the term that goes with x. Okay, so say if I'm gonna change it into something like, I don't know, -x squared plus 3 plus 4x, this is not my middle term. Okay, like middle term is meant for whatever variable or whatever term that is attached to x. It has to be x. If it's not like with x, it has to be like x squared or like a free number. You don't go with it. Okay, it has to be strictly with x. That's what I mean by the middle term. Okay, so make sure you don't get it like wrong. And then after I get the middle term, what do I do with this, right? So I'm gonna go ahead and take it divided by 2. I'm gonna get something like 2, right? But no, I'm not gonna go with it, right? So I'm gonna change the sign of it to -2, and this is what I want for a table of sign. And let me go ahead and cross this number out too before we all like get mistaken for this. So just like a really quick like note in here, make sure you change the number. I don't think I can squeeze it in, but okay, no, I can't squeeze it in. But in here, just make sure you change the sign, okay? So as for the XY table in here, let me go ahead and make another XY table. 1, 2, 3, 4, 5. All right. So what do we do, right? The number -2 will be the third chosen number in here. And then what do I do? I'm going to go ahead and move along the line. So this one I'm going to go like -1 and 0, -3 and -4. Right? It's just like 1 unit up and then 1 unit down, 2 unit up, 2 unit down. Okay? And now let me go ahead and plug it into the calculator to get the y values of these like x value. So that is, what is it? By the way, if you have like a Casio in there, it has like a function, table function. It allows you to plug in like the function and just plug in like the x values, and then you're gonna have the y values without having do it for each number of x. That's like really like nice. But I'm not sure if other calculators have that function too. Okay, so anyways, this number is gonna be 3 at the beginning, and let me switch it back to blue. So this is 3, and if you do -1, you're gonna get -2, and then -2, you're gonna get -9, which is like a big number, but we'll see about that. And then plug in -3. Again, I'm getting something weird, and again, you know right away that there's something weird with this like x table, right? Because the values in here are not symmetric. Okay, so let's see, where did I go wrong? Oh yeah. Okay. Honestly, usually I don't do by XY table, even though it's an easier method. I usually do by completing the square, like what we learned in the circle, but I notice a lot of people, they don't perform well with the unit circle. That's why I introduced you guys with this one. But it looks like it's going to be a little bit like hard to say at the beginning for this one. So what should I do in here? Here, let me first like backtrack a little bit about the numbers in here, and let me talk more about like this function in here. Okay, so I know that I told you guys we're gonna take the middle number, we'll divide by 2, and we change the sign, right? But unfortunately, as you can see, we don't have that symmetry in the XY table in here, so that the sign, there's something wrong, right? And I know why is wrong. is because of this like negative xy in here. What is it? Like this negative xy in here. If you were to have a negative in front, well, it's gonna be like double negative. So this one in here, you have to change it again into positive 2. Okay. And let me show you guys like another way to complete this way, like right after this. Hopefully it will be like easier, more convenient for you, because like the table of sign here, as you can see, is really picky with the scenarios. But if you know how to complete the square, it's gonna be like super simple. Okay, I'm gonna show you guys like 2 methods, but for now, okay, bear with me. Just trust me that it's gonna be a 2, a positive 2 for the middle number. Okay, so we're gonna have something like this. And some of you guys may ask me, is it always gonna be like 0, 1, 2, 3, 4 for all functions? And my answer is no. Okay, it just happened that in this problem, I make them have the same center, which means that they have the 2 in the middle row. Okay, but that's not gonna be like for all cases. Okay. So anyways, if you do it correctly in here, then you should have a 2 in between. I'm gonna show you guys like another way to know what numbers to plug in a minute. Okay. So anyways, we're gonna plug those numbers into the original function again, and then for 0, you're gonna end up having a 3 in here. For 1, you're gonna have a 6. For 2, you're gonna have a 7. And let's see if we got the XY table right this time. It is 6, which is a good sign, right? And then for 4, let's see what happens again. It is 3. So yay, we got it right? Okay, and next up, we're gonna plot them all out, right? So 0, 3 is like right here again, it's overlapped. And then 1, 6 is like 1, and then 6 right here. And then 2, 7 should be like right here. And then 3, 6 right here, symmetry. Excuse me. And then 4, 3 right here, right? And then we're gonna go ahead and connect all of them together. And then we have the second graph, okay? And then, like what I promised earlier, let me go ahead and share you guys how to know exactly what center we're gonna get for each time, so then we don't have to pay attention to like all the sign and the middle term and then all the things like that. Okay, so if you remember how to complete the square for this one in here, it's gonna be like x squared minus 4x, and then we're gonna have to plus an additional number in there. And then because we plus that number, we have to like minus that number out and then plus 3, right? And then we're gonna like put them together like this. Okay, actually it only matters for the first 3 terms. The other 2, it really doesn't matter. Okay, and what you're gonna do next is that you're gonna take this number divided by 2 and square it up. So negative 4 divided by 2, it is negative 2. Negative 2 squared, it is a 4, right? So whatever you have on the first blank, you're gonna use it on the second blank. Okay? And then to end this question, for completing the square, well, there's a lot of ways to do this one. So you can think about it like an X method, where you have negative 4 in here as the top part and 4 on the bottom, and you have to ask yourself, well, what are the 2 numbers that multiply together to get you negative 4? But then add, well, what numbers multiply? Okay, I think I switched the order. So it should be 4 up here, like this, for this number, and then the middle number should be on the bottom like this. And then ask yourself, what are the 2 numbers that multiply to 4, but at the same time add to negative 4? And then you realize that they are negative 2 and negative 2, right? So short step, you're gonna write something like x minus 2 twice. That's why we have the square in there. Okay, so let me put back the blank in here, and then the 4, and then let me just circle the middle number in here really quick like that. Okay, this one is an ugly 4. Okay, and now moving on. So these 2, if you combine them together, 3 minus 4, you're gonna get a negative 1, right? But anyways, that really doesn't matter anyways. So the thing is, well, as long as you get the x part, then you know the center. And if you pay attention to this one, the outside part, like the free number outside the parentheses, is actually your y value. Okay? So then if you want to do it with the blue one, here's the word for it. So first of all, rather than you have to like arrange them, right? So it's gonna go like negative x squared plus 4x plus 3, right? And I told you guys, whenever we have a front number, like if x squared is if it's not like x squared, we have to go ahead and factor it out, right? So now we have to factor everything out by negative 1, and we end up having x squared in here, negative 4x minus 3, right? All right, what do we do with this, right? So now we're gonna do negative in there, and then x squared, and then minus 4x, and then we're gonna plus a third number that we don't know, and because we plus it, we have to minus the exact value out, and then we keep the negative 3 like that. Okay? And then make sure you keep it as a habit of always like put parentheses over the first 3 terms for us to know that we're gonna complete the square for it. Okay? The other 2 terms outside, they don't matter a lot. Okay? So now we're gonna do the same thing in here. So I'm gonna take this one divided by 2 and then square it. So negative 4 divided by 2, I get negative 2. Square it, negative 2 times negative 2, and I have a 4, right? And whatever number we have for the first blank, we're gonna write again for the second blank. So now we're gonna get something like a negative outside, and then 2 parentheses like that, and then x minus 2 square for the same reasoning. Okay, like if you want, I can write them again. And then we have like a negative 4 on the bottom for the middle one, and then a 4 on the top, right? And then the answer will be the same, negative 2, negative 2. That's why I have negative 2 square in here. Okay, and on the outside, we have negative 4 minus 3, which is negative 7, like that. Okay, and then now, last step, we're gonna like break out of parentheses. So negative, and then x minus 2 squared, and then plus 7. Okay. So if you notice, the negative 2 in here is that 2 that you're having in here. Oh, by the way, I keep telling you guys like why we have like negative 2 on the function, and then we have a positive 2 in here, right? Okay, so a thing to notice in here is that we're gonna set this thing equal to 0, and then we're gonna get the center. So this equal to 0, so we're gonna get like x minus 2 equal to 0, which means that x equal to 2. That's why we have this 2 in here. And we're gonna do the same work in here, just because we have like x minus 2 on the inside. We're gonna do x minus 2 equal to 2, which means that x equals to 2 as for the center. Okay, let me see if I can change the color for this one. To, okay, I can't. I guess I can rewrite it. But I guess we can bring this one a little bit down so that I have space. Okay, so this one in here, we set it equal to 0 again to find a center. And the center in here is 2, just like what we have in here. Okay, and the outside number in here is positive 7. That's why we have a positive 7 in there. Okay, so to find a center, pretty much you have to, you know, complete the square. But you don't have to do it all the way down. Like as long as you get like the x factor, then you're pretty much done, right? Because like whatever you have for the number in there, if you negate it, you're gonna get the center. Okay, so if you need more practice on completing the square, let me know, because chances are you have to know how to grab the parabola for the test. Okay, anyways, so that's like the minor part in here. So now we're having the 2 graphs of the 2 functions already. That's good. So now let's talk about a question. What does it want us to do, right? It wants us to find the area in between of the 2 region. And then if you notice, right off the bat, we have 2 intersection, right? Which is 0, 3 and then 4, 3, right? So from there, the only area in between them, it's just gonna be this shaded region in pink. Okay? So now let me take all of this information out of the page. Okay. let me try to trace that one more time. Okay, here's a better one, I guess. Okay, but just in case you guys like cannot find intersection, okay, there's a way to find the intersection in between. Okay, so let me use, I don't know, pink for intersection. So what you want to do is that you're going to set this function equal to this function, right? So you're going to have something like x squared minus 4x plus 3 equals to 3 plus 4x minus x squared. And then we're going to get a 0 by like moving everything on one side by combining like terms. So it's going to be 2x squared because we go ahead and cancel this one and this one. Well, not cancel, but you know, like add them up, right? And on these two terms, it's going to turn out to be a negative 8x. And then 3 minus 3, we get a 0. Okay? So this step in here, you can go ahead and factor out a common term, which is 2x, right? And then you're going to end up having x minus 4. You set each of them equal to 0, so you get like 2x equal to 0, or x minus 4 equal to 0. And then you get x equal to 0 or x equal to 4, just like what we have in here for the x part, 0 and 4, right? So this is like just in case you don't see the intersections like right on the graphs, okay? But if you have them already, well, you don't have to show me how to find intersections anymore, okay? But chances are you're gonna have to do the intersections anyway, because it's not correct by, you know, like by sketching. It's not going to be like super perfect, and then it's hard to see the intersection points from the graph. Okay, so anyways, that's how we do it for the intersection. And now we're talking about the real business that we have to define here. All right, so we're going to have to find the area in between, which means we have to do integral, right? From where to where? We have to do it from 0 to 4 because those are the only two x values that we have. Okay, and then we notice that the blue function, this one is above the red function, this one. So what we're going to do is that we'll take the blue function in parentheses minus the red function, x squared minus 4x plus 3, and then dx at the end to compromise for the integral symbol, right? And then now what do we do? Well, we have to like combine the like terms, right? So this equals to 0 to 4, and then you're gonna have to like distribute the negatives in here, okay? And then combine the like terms. So I have negative x squared minus x squared, which is negative 2x squared, and then 4x plus 4x, that's 0 out, and then 3 minus 3, that's also 0 out, right? So we're gonna have dx in here, and guess what? I have a mistake. So this one, it would be like a positive 4, right? Together with another positive 4, I'm gonna get an 8 in here. Okay. So now what do we do, right? We're gonna have to integrate them, right? So negative 2x squared is gonna be negative 2x cubed divided by 3 plus 8x squared divided by 2. Integrating from 0 to 4. Okay, so this one, the rest of it is just, you know, like you plug in 4 and then you plug in 0, you get the two numbers, you subtract them, you get the answer. Okay, so this one I'm going to skip forward to the calculator part. So it's going to be 64 over 3 minus 0, which is 64 over 3, and that is the final answer. Okay, so this one is the main work, okay, like to find 0 and the 4 in here. It's not given from the problem, obviously, right? But then there's two ways to do it. Well, you can set the two functions equal to each other and find the intersection from the beginning, or you can base it off from the graphs of the two functions, right? Sometimes you need both ways. Sometimes it's just one way or the other, okay? And as for how do you know which one is like on top and which one is on the bottom so that you can like subtract which one from which? Well, that's one is really depending on the graph that you're having, okay? So that's what I do for my part, and then for your part, you're gonna have this example in here. Okay, and then yeah, for this one, for your part, you don't have to find the intersection anymore because I already like give you the limit. So just a heads up, for your part is gonna be going from like 1/2 to 1 because it's from the problem, right? Like here, let me clean the screen a little bit. Okay, from your part, you have it going from 1/2 to 1 because we always go from smaller number to bigger number, right? But then there could be like two ways to do it, right? It could be like 1 over x minus x cubed, or it could be like x cubed minus 1 over x, right? So this one, again, it really depends on the graph that you're having. Which one is on the top, then you minus it to the other one, okay? And then after that, well, dx in here, you integrate it, you plug in 1 and you plug in 1/2, minus them, you get the answer. Okay, so this is what you have to do for your graph. And just a heads up in here, we talking about this shaded region in green. Okay. So now let's move on to the second example. Okay, and this one, just a heads up, is you're gonna see it on the final. Okay, so make sure you pay really well attention to this one. All right, consumer surplus and producer surplus. Okay, in terms of business, it means a lot. Okay, so in section 1.2, we learned that a demand function relates the price of a product to the consumer demand. We also learned that the supply function relates the price of a product to producer's willingness to supply the product. So that's why we come up with two formulas in here. And I know this could be like a little bit confusing, but make sure you have them out in front of you on the test day and you'll be fine. For consumer surplus, what we're going to do is that we integrate the demand function minus the price function. Why is that so? Well, for consumer surplus, we're talking about this area in here in blue shaded, right? And as you can see, this function in here is the demand function. It's like on top, right? And then the price function, this one in here, is PO for the price. That's why we have to do demand minus PO, or the demand minus price. Okay. As for the producer surplus, let me do it in orange, I guess. We have to do the price minus the supplies function. And why is that so? If you notice, we're talking about this area in here in shaded orange. And obviously the supply function, this one is like beneath the price, right? So the surplus, this piece in here, is underneath of the price function. Okay, let me just finish my color coding, I guess. This one is for demand, and then let me change this one to, I don't know, like pink. That's why the position of the graphs are really important, okay? And how do we get the price? It's coming from the equilibrium point, okay? The y value of the equilibrium point. And it will make more sense when it comes to like real life practice. So let me give you guys a good example for this one first. Okay, so for my example, I have find the consumer and producer surpluses as assume that the demand and supply functions for a product are modeled respectively by this function and that function, where x is a number of unit, right? So let's color code it a little bit in here. Blue for demand function. Demand function is the first one, so it should be the first function like this. And then orange for the supply function. Second function, so it should be this function right here, right? All right, how do we do it? Well, to apply the formulas right here, we need the equilibrium point, right? Or else we're not going to get the price to do, right? So then how can we get the equilibrium point? Well, we're going to set the demand function equal to the supply function, like what we learned from the previous section, right? So then what do we do? How can we get it? Well, first thing first, we have to set them equal to each other. So we do 975 minus 23x equals to 42x, right? And then after that, we come by the like terms. So then this one is going to be 23 plus 42, which is 65x, equals to 975. So divide both sides by x by 65. And we get x equals to 15. Is that all we need? Is that the price? No, right? X is a unit. So we know that the unit of the equilibrium point is 15. But what is the price? We need the price, right? So what we're going to do is that we're going to plug 15 into either the demand function or the supply function. Okay? So in here, I'm going to go with the supply function because it's shorter. So my price P, it equals to 42 times 15, which is 630. So this is my price in pink. Let me highlight it in pink, just like what we had in here or here. Okay, so now what do we do, right? Let me get rid of this work now that we have it done. Okay, so we're talking about business in here. So consumer surplus, let me do it in blue. Consumer surplus, it equals to the integral going from 0 to x, and our x in here is 15, right? So let me use, I don't know, like paying for it again. 15. Okay, so demand function, what is the demand function? It is 975 minus 23 in parentheses because they're coming as a group, and minus the price, which is 630 and dx, right? And then let me put a wall to separate these. Okay, so what do we do after this? Well, we have to do the math out, right? So we have it going from 0 to 15, and then we're going to combine the like terms. So it goes like, okay, I'm missing an x in here, that's why. So it's going to be 975 minus 630, which is 345. 345, and then minus 23x, right, like this. And then now what do we do? Well, we have to integrate down, right? So it goes like 345x minus 23 x rated divided by 2. You're gonna plug in a number 15 and 0 in here. So let me go ahead and shrink this line a little bit further, and let me move this thing away. Okay. Okay, so this in here, if we plug in 15, we're going to get 345 times 15 minus 23 times 15 squared divided by 2, which is 2587.5. Okay, that's an ugly 7. And then minus 0, right, for the second go. So then the final answer in here is going to be 2587.5. Final answer. Okay. And now for the, what is it, for the producer surplus, we're going to do the same thing. But let me put the star in here first before I forget about your mission. So let me put it in orange in here, and let me use this space in here. Okay, producer surplus, PS, same deal. So we're gonna have it going from 0 to 15, because 15 is the x part of the equilibrium point. But we're gonna change again, right? It's gonna go like price minus the supplies function. So we're gonna do 630 minus 42x. Okay, some of you guys may ask me, well, do any parentheses in here? And I'm gonna tell you guys, well, if you want, you can put it there, but because this one, we only have like one term for the supply function. Parentheses or no parentheses, I don't think it's gonna be a big problem, okay? So for me personally, I don't like too much like details, so I'm gonna take out the parentheses. Okay, and then at the end, we're gonna have dx, right? So dx in here, and I'm gonna put parentheses over here because I need to integrate both of them, right? So now, same old game, right? We're gonna integrate them because we don't have any like terms to combine. And then we're gonna do 42 times x squared divided by 2. If you want, you can simplify it, because 42 divided by 2, it is 21, right? And we're gonna integrate it from 0 to 15. Right, and then this one, if you input 15 in here, what do we get? We're gonna get 47 25 minus 0. So the final answer in here is going to be 47.25. Done deal. Okay. So these are the surpluses that the question is asking for. Okay, so for your problem, you're going to do the same thing. Okay, so first at first, you have to find the equilibrium point. You get the x part for the limit, the upper limit, should I say, and then you get the y part for the price. Okay, after that, you apply the formula in here to find the consumer surplus and the producer surplus. Endgame, right? That's the answer. Okay, and now, before we move on to the next topic or the next objective in here, let me just confirm with the graph in here. So for consumer surplus, it's going to be ugly in here. Okay, I mixed up the color coding in here already, but then consumer surplus is going to be like this shaded area in here. Okay, and then for producer surplus, it's going to be this orange shading in here. Okay, so if I ask you to, like label the graph for the consumer surplus and producer surplus, make sure you remember that the consumer surplus is always above the producer surplus. Okay, and make sure you shade the right region. Okay, the surpluses, we're talking about area, we're talking about region in here. It's not like a line, it's not a point. Okay, so make sure you pay attention to that. And what do I also need or expect in the graph, right? I want to see the point of equilibrium, okay, and I want to see the line of the price. So make sure you have them labeled, and definitely label the the supply function and also the demand function. Okay, so this one and the other one, demand and supply function. Okay, and also like definitely like label the names, right? Like producer surplus and also consumer surplus. That is all that I expect to see in a graph in the final, if you have it. Okay? And now, last objective, application. Okay, in addition to consumer and producer surpluses, there are many other types of applications involving the area of the region bounded by two graphs. Okay, so there are many more applications, right? So then let me put a star in here just in case I forget for your part. All right, so now let's talk about my part. Epidemic was spreading, and after its outbreak, 2 weeks. So it's like after 2 weeks after it spread out, or like after 10 weeks after the spread out of it, it had infected and like this amount of people. Okay, like measure by this function right here. So let me like circle that function in here. What t in here is the people between 0 and 50, right? And 25 weeks after the outbreak. Okay, so this one, okay, let me just calculate it really quick. So 2 weeks, we have that function. After 25 weeks, a vaccine was administered to the public. At that point, the number of people infected is narrowed out to this function right here. Okay, so now I have to approximate the number of people that the vaccine prevented from becoming ill during the epidemic. Okay, so this is like, as you can see, this is very useful for all the like chemists or like the pharmacists during COVID-19, right? Because it's tell us like how to predict the amount of patients that are victim that we can cure during like the pandemic. So anyways, what should we do, right? So well, personal advice, first thing first, we have to graph them first, right? But then there's another trick to save you some time from graphing, and then you still know which one is like on top and which one is on the bottom. If you notice on the red function in here, the front number is a positive number, right? So we have like a 0.2 t squared. That's like the 0.1 in here is a positive number, which means that your parabola is gonna be upward like that. Okay, and for the pink function, if you notice, the front number in here is 0.2. So that means that your parabola is going to be a downward parabola, right? So now, okay, what do I mean by the front number anyways? The front number is like the number in front of the highest term or the highest power in here. So in the two functions in red and in pink in here, the highest power in here is t squared. That's why the front number of each of them will be like 0.1 and negative 0.2, okay? So if the functions are not like organized for you already, you have to arrange them from the highest power to the least power to tell your front numbers, okay? And now you have two scenarios that you can think of, right? So it could be something like this, it could be something like this, or in another scenario, it could be something like, I don't know, what else can you think of? I think it's just like those two functions, right? So it could happen like that, or it could happen like this, right? But for the first scenario in here, the two parabola that you like have, they have no contact with each other, right? So there's no area generated by like the two functions. So it's definitely not this case, right? So we talk about this case where like the like how to say this part in here and this part in here is on top of this part, and then this part in here is on top of the other part. Okay, so if we talked about like the pink area in here, then we're gonna do like the upside down u minus the u, and if we talked about the red area, then we're gonna do the u minus the upside down u. Okay, so first thing first, we have to find the intersection between them, right? So let me go ahead and set the two equations equal to each other. So I'm gonna get something like 0.1 t squared. Okay, personally I don't like t because it's like mistaken with the plus. So let me go ahead and change everything to x, okay? And if you want, you can do the same thing. I'm not gonna judge you for the variable. And then I'm gonna set it equal to the other function. But before that, let me go ahead and delete that. Okay, so 0.2 x squared plus 6x plus 200. Okay, so this is like calculus class, so I'm gonna move forward. I'm gonna like skip forward with the algebra in here. And then what do we have for the other one? If we were to combine the like term, we're gonna get something like 0.5 minus 6, which is negative 5.5. And then lastly, 150 minus 200, that is negative 50 equal to 0, right? If you want, you can use the quadratic formula for this one. If you don't want to, you can use decimals or something like that for this one. Various way. In the test, definitely go for the quadratic formula, okay? Anyhow, you're going to get x equals to negative 6.67 and x equals to 25. Okay, so those are the limit that we have. Lower limit in here and upper limit in here, right? So, let's start the work. We have the integral going from negative 6.67 all the way to 25. And how do we know which one is on top of which one, right? I know it's like, based on the graph, it's like really easy to tell, right? Like obviously in between, like the shaded region in here, it's gonna be blue minus red, right? But without a graph, that will be hard to tell. Okay, so make sure, I don't know, you graph them first. That's like the best advice for you guys. But most of the times, usually like the, how to say this, like the upside down U, this one in here, in pink, minus the other one. That's like for most of the time. It's this one minus this one. Okay? Because of the position of it and just, you know, like I have more practice, I guess it's just like instant. I know that if my A number or my front number is negative, that will be the function to go first. And if my A number or the front number happens to be a positive number, that will be the function like under subtraction. Okay? Anyhow, so let's plug in the functions in here. So I'm going to get negative 0.2 x squared, t squared, I don't really mind, 6, 200, and then minus, okay, I'm running out of space in here, so let me go ahead and move this one a little bit, like right there. You know what, I can write smaller in that a little bit, just to save some space. I want to keep everything on the same level, just so it's easier to follow. And then minus it to the other function, which is 0.1x squared plus 0.5x plus 150. And obviously we're going to have the dx at the end to compromise for the integral, right? Alright, what do we do after this? Well, combine in like terms, right? So we still have it going from negative 6.67 all the way to 25, but then our function is narrowed out to 0.3x squared, and then this is 5.5x, and then plus 50 dx. If you notice, the function that we get in here should be somewhat similar to the function that we get for the intersections. And that's a good sign that you did the right algebra. Okay? It's just like fun facts. Anyways, moving on. So, how can we integrate this? Well, we're going to do 0.3x cubed divided by 3. Okay? And if you want, you can like cancel the 3's in here. So, that would be like negative 0.1x cubed, right? So let me skip forward to that part and let me just put like 0.1 in here. And the next one we have 5.5 x squared divided by 2, and then 50x integrated from negative 6.67 all the way to 25. Okay, personally I don't really like it when we have like this situation of decimal on top of a fraction. It's kind of like weird. Okay, so if you were to give me something like that, please give me a decimal rather. Okay, so just go ahead and do the math for this one and give me something like 2.75 after you do that division. I'll look better rather than a combination of decimal and fraction. It kind of like looks annoying. Okay, anyhow, well, after this, what do? We're gonna plug in the two numbers in there, right? And then you're gonna get something like 1406.25 minus this number to plug in everywhere you have access, right? But wait, there's something like ridiculous about this problem so far, right? Like t in here, x in here, we're talking about number of people, right? And number of people cannot be negative. So this number in here is unreasonable a little bit, right? But how does it make sense with the graph, right? Because we have the intersection going from negative 6.67 all the way to 25. Well, in here, ignore this part. So let me put it in, I don't know, brow. We're gonna like skip this like brow part, okay? Because we're not gonna have something in negative people, okay? So anything on the left of the 0, we ignore it, okay? We're just gonna pay attention to the area between the two curves, between the two like functions in here, when it's greater than 0, when it's on the right hand side of 0. Okay, so to edit that mistake, what do? We're gonna replace everything in here by 0, because we cannot have like negative number of people, right? That's why, to compromise for that, let me put 0 in here. Okay, and obviously if you plug in 0, you're gonna get a 0 everywhere in here. But just a heads up, because I did this mistake like when I was you guys, so make sure you don't make the same mistake anymore, okay? Make sure when you get like an unreasonable number like this, don't take it, don't use it. It's there, but don't use it. It's there to trick you, okay? So just go with like x equal to 0 for the lower limit instead. Okay? And now, as for the final answer, we're gonna subtract the numbers in here, and we're gonna end up having 1406.25. Okay, so this is like the number of people that the vaccine prevented from becoming ill during the epidemic. Okay, but then wait, we're not done with it. Why are we not done with it? The number of people cannot be a decimal, right? Because it's weird. So the final answer, let me put it in green, it's gonna be 1407 people. Some of you guys may ask me, like, why do I have to route up, right? Like this part in here, if we route it, it's gonna be 14.06 people. But think about it, 0.25 people. What does it mean? Well, if anything, it's gonna have to be like a human, right? Like one count, right? It cannot be just 0 count. That's why for a number of people, you're always going to bump it up. So you always route up. Even if you get something like 1406.01, it's still going to be 1407 people. Okay, because we're talking about people in here. So if you have like 0.1 people, it's still going to be one count. Okay, so make sure you don't route it down. Don't route it the regular way that we route it. It's always have to be routed up. Okay, and that's the end of today. Thank you for your listening. If you have any questions, let me know. Email me, contact me, okay? And thank you for your listening. Take care and have a great day. Bye-bye.